Hi, and welcome to this introductory overview of ThermoFAST Desktop. To get started, let's go to the FENEX website. That's the website of the Future Energy Exports Research Center, and you can see the URL here. If you Google FENEX ThermoFAST, this page will typically be one of the top results. There's various things you can download from this page. For us, the download we want is ThermoFAST Desktop, the current release version, which is version 2.3.0. So click the download link, which will give you a zip file. If you unzip the zip file, you'll end up with a folder that looks like this. And you can copy this folder to whatever location suits you best. And that's the extent of the installation process for ThermoFAST. So the executable file, thermofastdesktop.exe, is the actual program. So let's double click that to open the program. When you first open it, you'll get a disclaimer window. After you've read this, you can uncheck this box and it won't appear in subsequent sessions. Once you've accepted that, you now get to the main ThermoFAST window. The layout of this window is a series of side panel buttons on the left, which sort of navigate through various stages of calculation, and a central panel where all the inputs and results of calculations are presented. So the first step in doing a calculation is to set up a fluid mixture. So let's begin by adding some fluid components. I'm going to add methane and ethane. I'm going to have just a binary mixture of those two. So when I double click in the available list, the component is moved to the selected column. If I double click back again, it's removed. And I can also use these arrow buttons to move components back and forth and also up and down, so I can reorder the list as I want. Okay, so now that I've added my components, I'm going to go to the composition window, and here I can choose the fraction of methane and ethane that I want. I'm just going to go with something simple. You can see that I've entered two numbers that add up to 1, so my mixture is already normalized. And that's the process of setting up a mixture. I'm now ready to do a calculation. So let's go to the Flash window. Now the sort of Flash calculation is the standard sort of calculation in thermodynamics. We have a mixture of feed containing given concentrations, and we want to work out under given pressure and temperature what phases will be present. So let's just demonstrate this. We'll choose a pressure and temperature that are kind of reasonable. Click on calculate. And the flash calculation has determined that at this P&T we have vapor and liquid phase. So the results here, there's several tabs, each containing a table of results. So the phases table tells you what phases are present in what fractions and what the densities of those phases are. Phase composition gives you the fraction of each component in each phase. So you can see here methane, being the more volatile component, is present as the majority in the vapor phase, and the liquid has ethane. The partial fugacities for each phase. So the fugacities are equal across all phases. Fugacity coefficients differ between phases because the concentrations are different. Finally, there's a table of phase properties. So there are properties that apply to the overall feed, that is across both phases, and then properties that apply within each phase. And you'll notice not every property is defined for every phase. Can I move on and look at solids calculations? So here the most common calculation is to identify the solid formation temperatures. So if I just again set a pressure, click calculate, it tells me that at 75 Kelvin, this mixture will turn from a liquid to a solid liquid equilibrium, and that solid methane will form. Okay, there's also a hydrates calculator. So this only applies to mixtures that contain water. So let's go back. Let's remove ethane and add water to the mixture. And I'm going to use fill balance here just to give that missing fraction. And I can go now to the hydrates tab, and what this will do is for a given pressure, this will tell me the temperature at which a hydrate phase becomes stable. And so this tells me that a hydrate S1, structure 1, forms at this temperature. And in the table below, I get various further bits of information telling me about in this case, methane is the only hydrate former, and also properties of the hydrate phase. You can also do the inverse. You can start with a temperature and find the hydrate formation pressure. You can see that the two give the same answer, which you would hope. And so now let's just also look at a couple of other things. So those are the main three calculation windows. There's also a tuning interface. I'm not going to discuss this, but this is used if you ever want to tune binary interaction parameters for a pair of components using experimental data. But let's go back. Let's go back all the way to our initial example. So I'm going to put ethane back into the mix. And for a given mixture, the first thing you can do on the composition tab is actually to plot a phase envelope. And that's the classic kind of VLE phase envelope. And this window also gives you various data. So there's the critical point, as well as the bubble point and dew point data. In the flash calculator, when you do a flash calculation, you can also do a diffusion coefficient calculation. I won't go into the details here, but if I click calculate on this, I'll get various tables of values related to diffusion coefficients for these two components. Within the solids calculator, there are several different calculations that are possible. So you can plot a precipitation curve, a solubility curve, and also a freezing propensity, which is a measure of how likely each component in the mixture is to freeze. I'll just demonstrate the solubility. So let's go back and add another component that's going to freeze out in an interesting way. So we'll just reduce ethane and add benzene to that mixture. And now I can view a solubility curve. So here you get a range of pressures and temperatures. I'm just going to do a constant pressure and let the temperature range from 90 to, let's make it 280. And so you see here the solubility with the logarithmic vertical axis. You can see the solubility decreases here. Then when methane turns into a liquid, it increases again and then goes back down. And you can also see the table of data for that. So the similar interfaces for the precipitation and freezing propensity curves. Finally, back in the hydrates window, there's a hydrate equilibrium curve. I won't plot that here, but that's similar to the precipitation curve, but it requires a mixture with water. And just to wrap up here, let me quickly go over some of the features in the menu at the top here. You can see all the calculations I've been doing have been in the default unit sets, but at any point here you can change the different units for each type of input. And you can also go to the units menu and change into different unit sets. So we have a number of predefined combinations of units. You can also bring up a custom interface to choose every unit to be something specific. Something I haven't talked about yet, models. So ThermoFAST, the way it normally works is you specify a set of components and it will actually choose the default set of models. You'll see here for the two component mixture, it's going for a cubic Peng-Robinson, classical solid model, and our default hydrate model. There's several other things that can be changed here. So the main thing to note, you should generally not need to come in here and change anything, but if for some reason you do want to experiment with other models, you can do that by unticking this box here, and now all of these become editable. And so you can see whatever models are valid for the mixture that you have, you can choose. Okay, so that's the models tab. Uh, there's also the file window here, which just has the usual obvious things. You can save your settings, you can import mixtures and component sets, you can export the feed that you've defined into a JSON file. And there's also a handy thing here. You can go, so ThermoFAST saves data related to your settings and also mixtures that you save into a user data folder, which is in your documents folder in your Windows folder. So to get to that, this menu item here gives you a shortcut. And you can see here inside my ThermoFAST window, I've got a bunch of different things that have been saved. So like I say, you can save component sets. You can save mixtures, and that when you save those will show up as JSON files in this folder here. You don't generally need to come in here and do anything, but it's occasionally handy if you want to share it or copy it to a different machine somewhere else. And then just finally, there's a tools menu, which is a kind of grab bag of various things that are also featured elsewhere. There's buttons for these in different calculators, but they're collected here as a way of bringing them into a single place. One thing that I haven't mentioned is kind of a standalone calculator for equilibrium hydrogen. You can come in here and actually calculate the ortho para fractions as a function of temperature, which is occasionally a useful thing. Okay, thanks for your attention. And with that, I'll wrap up this introductory video on ThermoFAST Desktop. Thanks.